Hi, everyone. Thank you for joining us today. I'm so excited to share this space with you today, and I thank you for taking the time to join us. We will just do an acknowledgement to country, so we acknowledge and pay our respects to all of the traditional custodians of the land and waterways on which we are all coming and working on from today. We respect and want to pay our respect to those elders, past and present, and would like to extend that respect to the Aboriginal and Torres Strait Islander people here today as well. Thank you, Holly. Okay, so today, as Holly said, we've got a packed agenda for you. I'm Harshita. I'm going to be your host today. So thank you so much for letting me host you, and I'm honored to be here. We are also going to hear today from our Potash team that are based out in Canada. So that's Chris and Kathleen. And we're also going to hear from our friendly faces that you are probably all very familiar with, Jess and Holly as well, who are going to help us facilitate the Q&A and keep us in check as well. All right, Holly, let's kick this off. So who is Think and Act Differently? Well, Think and Act Differently is the innovation arm of BHP, but we are really just a group of people who are curious. We like to challenge the norms, and really what brings us together is that we want to find new ways to tackle some of the big challenges that are ahead of us to support growth in the minerals that the world will need. You can see we're a big group of people there on the right hand side. We've got a team spaced all around the world, so hoping to be able to work together with you. Let's move on to the next slide there, Holly. As a part of the Think and Act Differently team, I have a really fun role in being able to curate what it means to be in a cohort. So some of you have worked with us previously are familiar with what it means to be a part of a cohort, but those that are joining us more recently, if you apply to one of our open calls and are selected, you'll join us on a journey where you'll get to collaborate with us in a small group type environment. And sometimes you'll be working on themes that are similar, but sometimes you'll be working on different parts of the process. We think that it's a good way for you to connect, to showcase, and really get to test your risky assumption with us. We want to be able to support you through providing resources. So whether that's funding, it may be some samples you need of our ore, or it may be mentors. And we're here to support you through that. So what's ongoing at the moment is the in situ recovery cohort, and that's through also being supported through our TAG joint venture, which you can see is with Rio Tinto, IGO, South 32 and Boliden. And what an awesome opportunity for you to have to be able to also learn from them, for us to learn from them and work together. Underway in curation, because we do spend a lot of time trying to think about what is going to be a part of our cohort. And so we closed our challenges in preconditioning, rock, critical minerals, and carbon economy some months ago, and that work is well underway to selecting those cohort members, and an announcement very soon to come. And finally, something very exciting as well, and I know many of you may have submitted, or at least I hope many of you have submitted some submissions to our biometals and comminution challenges that have recently closed. And open calls are not the only way you can connect with us on your idea. So I'm going to pass over to Holly to talk us through the open house.
Thanks, Harshita. Yeah, the open house, really happy to share with you more about this. I know a lot of you are familiar with the open house and how we run it. If you scan that QR code there, it will take you to the open house site. So the open house is always open. And we have talked about the open house in this name as a way of talking about how do we come together in an open space to talk about ideas, talk about the problems that we have, and get together to think about how we might solve them. So the open house is a place for you to come and submit your innovative ideas, your solutions, and to seek support for funding and to trial your untested ideas in the environment that Harshita just talked about with the cohorts. So the open house is the way to kind of initially engage in seeking your interest to take part in one of the cohorts. So you'll see that we've recently launched, which we'll talk about today, a new opportunity. You can submit through the open house for that, and then we'll form a cohort around that opportunity where you can all work together. So open house is definitely the way to get involved. The key thing to remember about the open house is we do have specific themes, like Harshita mentioned, that run at any time. But we also have the general open house, which you can submit to at any time with any idea, and we'll make sure that gets funneled through to the right people so that you get some feedback on that and get that assessed. So there's plenty of different opportunities regardless of the idea that you have. So yeah, hope to see many of you more through the open house. And I just wanted to give you a super quick rundown because part of my role of working with the Unearth team and the Unearth team directly is to run these open calls and engage with the most amazing companies and individuals and universities around the world. So we're really excited to have just closed 2 of the open calls, which Harshita mentioned we're now working through to form new cohorts. So one of those was biometals, which was absolutely fascinating to see all the people working around the world on really interesting biotechnologies and how they can apply it to mining. So we had really, really great engagement with that open call, and you can see some of the really interesting companies that came through here. And I know there's a few people on the call that got involved. So thank you very much. And it was fascinating to see where this discipline is going. We also just closed off comminution open call as well. And likewise, just got a fascinating, really, really broad range of universities and well-established players, as well as startups that are working on really unique technologies as well. So we're really excited to see how, as a team, we can support getting some of these technologies to that next stage and working with you all as well. So now I am going to hand over to Chris, if Chris is online, to introduce our very latest open call from the team in Canada. So over to you, Chris. I think it may not let you take control, but let's see how you go. You might still need me to change this slides for you. We'll see if I can change that quickly. Are you there, Chris?
Yes, sorry, I realized after all this time using Zoom and all the teams, I'm still forgetting to turn my mute off. So my apologies. Hi everyone. My name's Chris Meyerhofer. I have worked in potash innovation for about just over 10 years in an engineering capacity. So I'm really excited for everyone to be here. And as my wife can attest, anyone who will listen, I love talking about potash processing. So this is an exciting opportunity. I'm glad everyone's here. So I'm newer to BHP, given that the potash commodity that they're developing is new to BHP as well. So it's one of the first things I noticed starting with BHP was this concept of, the things like the open house and this ecosystem that they're trying to develop. So I think that's a really cool avenue to get ideas into our business and to help drive value as well as the societal benefits as well. So I definitely encourage you to ask questions if there's any things I can clear up, as well as to submit any ideas after this. So one of the things, I guess, as for those who have had a chance to kind of read through some of the documentation, we're looking for support on potash drying. So what I'm going to go through is I'll have a brief description on what is potash for those who haven't had the opportunity to be exposed to it. I'll go through some of the general processing of potash, so you have kind of an idea of, when we refer to potash drying, we're in the process and how does it get to that point. And then we'll go into some of the details on what is involved with potash drying and where some of the opportunities lie. And hopefully you guys will have lots of great ideas on how we can improve it. So just want to go to the next slide. So what is potash? So the fun fact for everyone today is The first US patent, which I think was around 1790, was actually a patent from Samuel Jackson, and it was to process potash. So that was the first US patent that was ever filed, and it was even signed by George Washington. So potash has been around for a really long time, and the original process for potash was actually getting potassium out of trees. So they used to like burn them down some way and basically burn down a tree, and that's how they would extract the potassium. So that's where the name actually derived from, is this original process of extracting potassium from trees. So when we refer to potash, it's basically some sort of potassium-rich mineral. And so the main component of what is potash is it's used for fertilizer. And so not that I'm a process engineering background, I'm not an agronomist, but essentially in order to maintain and increase some of the crop yields that we rely on for food security, crops basically need a certain amount of nutrients. And so potassium is one of the kind of the big three. There's nitrogen, phosphate, and potassium. So potash is what supplies that potassium component. And it's kind of like an interesting relationship. So if, for example, a crop does have, you know, a lot of nitrogen and phosphate available, but they have very little potassium, basically they're restricted by the lowest availability source. So essentially, if all of a sudden we stopped producing potash and there wasn't potash in the world, our crop yields would decrease to a point where we'd really suffer, and food security would be really hampered. So it's an interesting and really important mineral that's being mined. And so when BHP, as I mentioned, it's new to their commodity base. Like obviously they're really known for iron ore, copper, nickel, all those kind of common metals that we hear about. But when they're looking at making a huge investment in developing and thinking for the next 100 years into the future, where can they invest? They decided that potash seemed to be kind of fit their value proposition, where they can it required a lot of capital, a lot of the resource to extract this material. So they see it as a very long-term commodity. And from a food security standpoint, there's just this long-term mega trend. So yeah, that's generally what is potash. And I'll just get into some of the processing around it. Not that this is specifically or critically important to understanding air or why we dry it, but it's good to at least have some kind of concept of the general process. So this is kind of a generalized flow sheet that BHP, with their building of their new potash facility in Saskatchewan, Canada, which I am calling from Saskatoon, which is really close to the project. And that's, for those who aren't familiar with Canada, Saskatchewan's kind of like right in the middle of the country, and we seem to have a pretty big chunk of really good deposits for potash. And so that's kind of the two locations internationally where there is a lot of potash is Russia, Belarus, and then Canada. So a good portion, I think it's roughly 80% of potash comes between those two sources. So with the Ukrainian war and things like that, there was definitely an impact to the potash demand, and has increased, and trying to find countries that have a secure source has always been important. So just so you have some background on that as well. So what it looks like when we mine it, it comes up as a kind of a salt. And so potassium chloride is very similar to sodium chloride, which is table salt. And so our ore that we bring up is typically around 40% KCl. The rest is about 10% clays. And then the other remainder is that NaCl, or sodium fluoride. And so our whole entire process that we're trying to achieve is basically take ore that's 40% potassium chloride and bring it all the way to greater than 95% potassium chloride. So everything you see on this flow sheet is attempting to make that happen. So we bring it up, like with most minerals, we crush it down to a certain size fraction. And currently the most kind of economical, common way to recover and upgrade the potash or the potassium chloride is using a flotation process. And so in order to make it float, we have to do a little bit of scrubbing prior to the flotation process, where we remove some of the clays. And then from there, after the flotation process, it's still in kind of like a wet concentrate. And so this is where we have to dewater it and dry it to basically a final product. So the first stage where we take it down from 40% moisture is using kind of centrifuges. That doesn't require a ton of energy. And then we have kind of this moist, almost think of like beach sand that's kind of, you can kind of make a sand cap. So that's kind of the consistency that you can imagine, and even similar in size fraction. And so we have to take that kind of beach sand, wet, moist sand, and bring it all the way down to something that's like absolutely completely dry. And that's pretty important in order to ship it and make sure that it doesn't show up to a farmer as like a dried block, because you can imagine if there's any moisture in the product, it's a salt, it'll bridge and basically form a concrete chunk. So that's generally what the process flow diagram goes by. There is some other additional processes where we can recover it, whether it's crystallization, solution mining is another common process, but really the drying component is very similar between all types of potash processing, as we end up with some sort of moist concentrate that we need to dry in order to produce a final product. And so I'll just get into more details of the drying process that is kind of currently used. And this isn't specific to our Jansen project that we're building. This is a fairly commonality between pretty much all potash producers in the world today, is that they use some sort of, whether it's a fluid bed dryer or rotary dryer, they are essentially taking natural gas, which is methane. They're using a combustion process, generate a bunch of hot air, and they basically use that hot air to evaporate all the moisture off of the potash, and that produces a dry product. It also results in the product being quite hot, just with all that hot air in order to evaporate that moisture, results in heating up the product as well. And then there's a process where we try to make sure that some of the particulates that have been evaporated off some of the finer material doesn't just get blown into the air. So there's some pollution abatement equipment. And then, yes, just to clarify, it is an important process to look for alternative ways to make this work, just given that it does require a ton of energy, and it contributes probably the largest scope 1 emissions. And so for people not familiar with what scope 1 refers to, it's basically emissions that are generated on site. So scope 2 would be things like emissions generated from inputs into the process. So like electricity is a big one, but scope 1 or anything that within our plant that we're generating. So about 70% we anticipate of our scope 1 emissions is just from trying to dry potash. So trying to make a process that is has a low carbon footprint, focusing and coming up with a better way of drying potash is our biggest opportunity. So I'll just go into the next slide. So at the end of the day, the overall goal is that we really want to make a net zero potash mine, and we need to achieve that by 2050, but the sooner the better. And so focusing on some of our scope 1 emissions, which really is a lot to do with the drying process. So trying to get rid of that natural gas combustion process. So there's kind of a whole host of potential solutions that we're exploring, but we really are looking for ideas on what things everyone can suggest from their industries and their area of expertise. So kind of an interesting pie chart that kind of helps to facilitate the discussion on why is there opportunity in drying potash. You can see like the energy efficiency isn't great when really we use a ton of energy to try to dry the potash, which is basically just evaporating the water. And so really only 30% of the energy that we put into the process actually results in doing that evaporation process. Water also does take a lot of energy to evaporate. It results in we have to heat the product up because it gets heated in this process. So we spend a lot of energy just simply heating up our product. We heat up a lot of air, 20%. So you can imagine coming out of the stack, there's just a ton of hot air that basically gets emitted. We use a lot of energy just trying to maintain that fluidization. So, looking at ways of, can we do, drying at maybe potentially a lower temperature? Can we look at different types of technology that maybe, uses ways of removing that water, different types of potentially fluids or displacing that? Like, we're just looking for basically any types of suggestions that we can, use less energy and get rid of using that natural gas combustion process. So as I mentioned, some of the constraints are, we are located in Saskatchewan. So there's, it is cold. So looking at some of those energy sources, whether it's solar or concentrated solar, sometimes we're limited, but there's still possibility there. Our energy does come from the grid, which currently is fairly a high proportion of coal right now. So unfortunately, electricity isn't clean, but we anticipate by 2050 that our grid will be clean. So utilizing electricity to the drying process is something we're looking to consider. And, ideally, we do want to find a process that is cost competitive and comparable to our existing process, which is tricky. And one of the reasons that the industry still utilizes inexpensive, but with things like carbon tax and things, it helps with the economics and making it comparable to using some potentially other sources of energy that results in a lower. And then we still have to, at the end of the day, make sure that our moisture content is quite low, and usually we use the 0.2%. And I think that's all I had, Holly. So I think we have time for questions. Hopefully I didn't go too quickly or ramble too much, but yeah.
No, that was amazing. Thank
What's
you
the
so
next
much.
steps here, Holly?
Thank you so much, Chris. And I love your passion for potash. And I always just get so fascinated. It's a commodity I don't know much about. So I love hearing from you. I learn so much each time. And I didn't even know the origin of the name. So that was cool to learn. We do have a bunch of questions, and thank you so much, Kathlene, for jumping on and answering those. I might just pass back to Harshita for another couple of slides, and then we'll get back to all the questions, all the Q&A session.
Awesome. Thanks again, Chris. I always also just love hearing more about potash. Again, don't know much about it, so thank you. So the ecosystem, through Think and Act Differently, we have supported directly 50 innovators over the last few years, and we've been able to help them progress some of their ideas. And our ecosystem continues to grow. So we currently have 3,000 and growing friends joining in our ecosystem. So we hope that you will consider and come join us. On the next slide, Holly, I'm just going to round out and really start to jump into those Q&A. But I just wanted to quickly put another note out there to say, we want to connect with you. We're curious to learn about you and your idea. We've got some opportunity to be able to connect you into the technical expertise at BHP, but also through the joint venture that I mentioned earlier. So if you need any help, if you need any support, please do reach out. We are not seeking to take any of your IP, your background IP stays yours, but we are curious to learn how we can help you de-risk your idea. And we're really focused on building an environment that's collaborative, it's vibrant, it's fun, that you'll hopefully form new connections in that'll help grow and accelerate your idea. And you'll want to keep coming back to working with us. So thank you again for joining us and allowing me to host you today. But I think the Q&A is going to be the fun part here. So Holly, Jess, over back to you.
Thanks, Harshita. And I will stop sharing so we can see everyone's beautiful faces. And thank you. We've had so many questions come through the chat already. And yeah, like Kathlene, thank you so much for jumping on and chatting. You guys haven't heard from Kathlene, but she works very closely with Chris on the Potash and innovation as well. So yeah, please continue to put your questions in the chat. If you'd like to put your hand up and come off video as well, please feel free. I will start running down these from the top as well, just to make sure that we've got anything captured. But I might quickly, while I'm doing that, ask Kathlene, if you don't mind, or Chris coming up, and if because we have had quite a lot of technical questions, is there any of those that you wanted to talk to directly?
I was just answering one about bulk density, but maybe I can just answer that here. So I don't know the number off the top of my head, but our solids have a bulk density of 2 as we enter the drying phase. We carry a brine as the fluid, as potash is soluble, so everything has to be a saturated brine. And our bulk density of the brine is 1.23. So we'd be about 3 to 5% moisture if you want to do the math on the side. I don't have my Excel spreadsheet open.
Awesome.
Yeah, that's a good thing to clarify. Yeah, I refer to it as moisture and water, but just to clarify, yes, it is in a saturated brine. So it's yeah, it's not just water, it's a saturated brine as well.
And Angela's just asked if you've considered geothermal for the drying. Chris,
Yes, we're in the process for sure. Yeah. So yeah, geothermal is an interesting one. Given our current location, I think the kind of the hottest temperatures we can anticipate to get from our geothermal reservoirs is around 200, maybe 250, and that's very deep. So we're actually working with a Canadian-based company that's developing a geothermal technology that can actually economically recover some of this temperature. But that ties us to our next problem is how do we utilize this temperature heat, because that's fairly low grade, 200 degrees. So you trying to develop a process that can take a lower grade heat to do the drying in an efficient way. That's where we need to find a drying solution for taking that lower grade heat.
Awesome. Thanks, Chris. And we've got a couple of questions that's on the brine. So question, is there any other volatiles in the mixture besides some water left over from flotation? And then what are the anions in the brine? Is it just chloride?
It's fully saturated KCl and NaCl brine. So you got the potassium, the chlorides, and the sodium. We also get a little bit of magnesium in there that influences the saturation a little bit from the contaminants in our ore. So highly corrosive stuff.
We had a question further up from Brenton. You may have answered this, so apologies if it's duplicating, but how does the fluid bed process compare to rotary drying?
Yeah, that was a fantastic question. And I'll maybe tag team this with Chris because I think he'll have a better answer than me. But I would just say that there is rotary drying in potash conventionally, and we do get excited that there can be potentially higher energy efficiency use in a rotary dryer. But typically, potash producers steer towards fluid bed dryers as they were smaller footprint and less capital, even though they don't have the same energy efficiency. And Chris has been doing a ton of work in that space, so that's why I'll pass it over to him.
Sure. So I didn't get too specific into what a fluid bed looks like, but you can imagine what a fluidized bed is. It's essentially using air that comes from the bottom, and it's like a tank, and it kind of looks like almost like popcorn popping. You kind of get this air, and the goal is to have a really high heat transfer between your hot air and your particles. So that's kind of the goal of the fluidized bed dryer. And like Kathlene mentioned, it's a fairly small footprint, where a rotary dryer, for those who aren't familiar, it's like essentially a really big, long dryer, and it kind of just like rotates, and you get that contact between the hot air and the product just by almost tumbling it, and you, as it kind of like cascades in the drum, that's how you get your contact. But one of the limitations with a rotary dryer is they're quite big. So that's one thing that we've been exploring is alternative kind of rotary dryers that potentially use lower grade heat to be able to achieve that. But yeah, that's definitely been considered as an option.
Thanks. And there's another follow-on question, which I think kind of gets to this is, are there any size limitations on the solution? How big is the current natural gas dryer sized?
Yeah, that's a good question. So we anticipate, so we're kind of committed to our current design right now for the first 2 stages of Jansen. And so I didn't get too much into the production numbers, but the stage 1, which has been approved, and we'll expect to have running by 2026. That'll use a rotary dry or a fluid bed dryer, and the next stage, which has been approved, will be ready for 2029. So unfortunately, since we don't have an alternative ready to go right now, we're already committed to those. And so what we're thinking is, if we were to utilize a drying technology, it would likely be for the future stages, as well as potentially just removing those and having a separate space, so we're not constrained by the footprint of the solution, because it's pretty easy to imagine that if we want to use any type of other lower temperature heat that's not from a combustion process, it tends to require a larger retention time, which translates into more footprint. And right now the plants are pretty designed efficiently, which means there's not a lot of footprint or additional area. So we don't want anyone to be constrained by trying to fit into a certain space. We're in Saskatchewan, so outside of the plant, there's relatively a decent amount of area that we'd likely expand into if we're considering other drying technologies. So yeah, don't be constrained by footprint.
Thanks, Chris. All right, a couple of the technical questions, and then I might there's a question from Riaz which I might ask Jess to answer once we've gone through the next 2 technical ones. So Chris, a couple of other questions for you. Have you experimented with microwaves, and what are the weight percentage moisture as inputs for stage 1 and stage 2 processes?
So on the microwave
yeah,
question first, maybe. We've looked at microwaves and radio frequency a bit. I think it could be explored more. Radio frequency was more favorable than microwaves from our perspective, just because of the energy input that we would require. The challenging part is how you use the microwaves once the moisture gets down really low. So we're starting with a 3 to 5 weight percent moisture in the feed. Getting down to that 1% is something you can do with radio frequency. The challenge comes, how many stages of treatment do you need to get down to the 0.2 weight percent or less that we require?
Amazing.
It's a cool technology too, because I think you guys can imagine when you microwave something, you tend to target moisture, and that's just the way that microwave energy works. So if we can design a process that almost targets heating up the water, you can have an overall less energy input to do your drying process, because you don't result in heating up the product as much. And so that's something we've been exploring, as Kathlene mentioned.
Cool. So still maybe a potential, just got to think about it a little bit differently.
Exactly. Yeah.
Love it. All right. Just if you wouldn't mind, there's a really interesting question that's come through around how does TAD consider technology proposals that are geared more towards internal processes such as digital twins, IoT, 3D models, and equipment maintenance?
Yeah, look, that's a great question. And hi, everybody. I'm Jess. I work in the ecosystem team at TAD as well, if we haven't met before, though I do recognize a lot of your names. Look, we always talk about the what and the how in TAD. And so we have talked a lot about the what today, and I'm never, ever, ever going to stop learning about potash. I think Kathlene and Chris are just fonts of information. So thank you again for being on the call today. We also look at a lot of how enabling modules and technologies. So my encouragement is still put those ideas through. What we're always asking, though, is what's different than what we can buy off the shelf today. So a lot of the submissions we see are people looking just to sell products that are already well established within the mining industry. And while there's a time and place for that, we're really focused on innovative unlocks. So how is your idea different and novel, and how could we use it differently to make step change? So absolutely, there is no theme or technology that's off the table, but what you want to try to de-risk together is really where we're curious.
Thanks, Jess. And I'll just emphasize from the Unearth perspective, as we go through and support people with the submissions, that the big thing that we always give people feedback on is that value proposition and differentiation. So I'd encourage you in your communication with the team to really think about how you articulate that point of difference really clearly, because that's a really important thing to do. All right, please keep the questions coming, whether they're super technical on potash or the general, happy to talk through any of those mechanisms as well. On the potash specifically, that opportunity is open, I think, until somewhere early March. So you've got a little bit of time to get something in. We want to make sure you've got enough time to think about this and apply. So yeah, please keep the questions coming in. I think there's a couple more coming in now. Curtis has asked, if we apply for our idea, is the capital given to de-risk the solution? Are there goals to fund a full-scale prototype? So I think, yeah, talking about, I guess, the process that within TAD that goes from, yeah, the initial test and then future pathways. Jess or Harshita, who would want to take that one?
Sure. Yes, absolutely. I mean, initially, we want to really get an understanding of how we can de-risk your solution and what it is that where it may apply. But if there is potential there for us to grow and develop together, we want technologies to succeed, and we've got avenues throughout our Think and Act Differently team to be able to support what a pilot may look like in the longer term future. At the moment, we'd like to see what we can do to de-risk together.
Thanks, Harshita. And similar question from James, and I'm not sure how much we can share, and I don't know who is the best to answer this, and Brett, I can see you're on the call as well, but is there anything more we can share about the evaluation process and implementation, and like what are maybe the stage gates to go through that different like early stage and then later stage pilots? It's a great question.
Good way to have a go at that.
Thanks, Brett.
I'm happy to have a go at that. So I guess maybe just building on what Harshita was talking about, the first stage is the stage that the ecosystem team run. And so we're very, very focused on short, sharp, low-cost experiments. We want to get to know you. We want to see if there's a good cultural fit as well. We only like to work with people that we like to work with. And we want to de-risk your technology and understand what the value proposition is in a small way first before we commit to large-scale testing. But our overall innovation process at TAD allows for and is very much geared towards eventual implementation. So you can imagine starting out small, but gradually through our process, we would funnel great ideas where we've got a clear value proposition into our product team, and that's where the product team will do much larger development programs, longer dated, larger amounts of funding, with an eventual plan to either implement within an existing operation or add the technology to a concept of operations for a future asset or a future opportunity. So there's stage gates along the way, very much focused on the value proposition and the value created and the de-risking that has taken place in the context of whether it's an operational opportunity or a future concept of operations opportunity. Hopefully that's enough color.
That was awesome. Thank you, Brett. And this has caused lots of other similar questions to come through. I'll take the one from Steve on typically how long is the review process after an open house closes. So I just want to make 2 comments on this. So we do have kind of almost like 2 streams. So with the opportunities like Potash specifically, there is a specific closing point. And the general open house, we have a review once a quarter. So you can see on both of those pages what those kind of dates are. So you can see when we'll get to the review phase for both. Typically we try and obviously get through the review process as fast as we can. We do just run through a bit of a short list, and then the team gets straight into reviewing. Brett facilitates quite a large review panel with a lot of experts to review all of the submissions. So typically that can take between around 4 weeks. And then we move into the next phase after that would be one-on-one conversations with the TAD team. I know in the past that has been a little bit longer as we kind of had some transition internally, but we're getting back to our regular cadence, and that's that time frame's coming down. I don't know if anyone else from the team wants to comment on that as along with an answer to Stefano's question, which was, is there anything we can add on the follow-up from the validation stage once a pilot project has been successful in validating a technology with a clear value? What mechanisms are in place to enable adoption within BHP? Right, I might ping you if you don't mind taking on that one.
Sorry, is that a question for me?
Yeah, if you don't mind. So from Stefano just asking, like, what are the mechanisms in place to enable adoption within BHP once something's kind of been proven at a later stage pilot?
Yep. Hey, Stefano, it's good to see you, or I can't actually see you.
Hi. Hi, Brett.
Oh, there you are. How you going?
Yeah.
Yeah, as I was saying before, I think there's two targets for us. There's existing operations, and then there's future concepts of operations. And so we work really closely with the assets on future resource development opportunities, and also with the existing operations. And so tied up also with the future operations piece is also our growth pipeline as well. So there's kind of two avenues. There's an avenue into an existing operation, or there's an avenue into a future operation. And we are part of the processes for both of those from an innovation perspective. So we are your funnel into both of those, and we have the right connections into both of those pathways. And so the key thing is the value proposition, Stefano. So we need to be clear about what that is, and there needs to be a need for that value proposition within the business.
Thanks, Brett. And I also want to just highlight what Harshita mentioned before around the joint venture, and that people that come through the cohorts often have, and the open house, the joint venture partners are often a great list of additional mining companies that you can get exposure to through that process as well. So we are kind of running out a little bit on the questions, so I'll give people a few more minutes to pop anything else in. Here we go, a few more comes in, and then once we kind of trail off on the questions, I'll pass back to Harshita to close out. Curtis, I'll quickly answer your question. Yes, absolutely, a US team can apply. This is totally global, so we actually have probably just as many submissions from outside of Australia as within. Many of the people that are working with the TAD team currently are all around the world, which is fabulous. So yes, definitely encourage anyone from wherever you are to apply. And then this is a question from Phil. I'm not sure who can take this one. How does BHP value Scope 1 emissions?
I can maybe try to answer that one. BHP internally has put together a cost of emissions based on regions. So we don't have one approach, as the cost of emissions can vary based on the country. But globally, BHP shares the same ambitions that we want to eliminate both Scope 1 and Scope 2 emissions by 2050. And then regions sometimes have more ambitious internal targets than that, but that's our public statement that we're all chasing.
Amazing, thank you. And Curtis has also asked, what is the current water and natural gas usage for the drying process, I'm guessing?
I think we'd have to get into that under an NDA.
Okay, cool. Fair enough. Amazing. So another technical question, what do you do to manage moisture content during delivery to the customer? Is the product still typically less than 0.2% upon delivery?
So potash is hygroscopic, which means that it wants to pull moisture out of the air and it wants to cake together. So it's very important that we get this drying step right. Dropping that moisture down to 0.2 weight % or less is critical. We do that through a natural gas fired fluid bed dryer today. And then as we move to storage and prepare to ship via train and ship to our customers around the world, we put on a coating that is an anti-caking agent that protects the particles.
Amazing, fascinating. All right,
That's gonna be a whole other challenge.
Yeah.
Well, but that was another problem to solve is the anti-caking, because you can imagine sending it to places like Brazil where there's really high humidity. It's sometimes hard to control, and they do end up with bricks every once in a while of caked potash. So that's a good question.
And if anyone, while you're listening, if any of these other things to come up and you have ideas, feel free to submit them through the open house as well as general, like if you've got other stuff on this stuff, and the guys will take a look at it. So yeah, interesting to hear all the other challenges in the process. All right, it looks like I think we're tailing off on the questions. So I just wanted to make sure I open the floor if anyone else from the TAD team or anyone else would like to say anything before I close out the session, or pass back to Harshita to close out the session. Oh, good. All right, Harshita, I will pass back to you to close out, and I'll just make a quick note that I will send the recording around in a couple of days to everyone as well that's registered for this. And any other questions you have at any time, please reach out to any of us. I'll just pop my email in the chat, and so you can do that as well. All right, over to you, Harshita, to close out.
Thanks, Holly. Thank you, everyone, for joining us today and for all of your awesome questions. I've also learned a lot about the Potash process just through your questions as well. So thank you so much. And yeah, I look forward to connecting with you online again at the next webinar. But also, I hope that you will support us through the open call on the potash drying process, the new ones upcoming. And like Holly mentioned, if you feel like it doesn't quite fit in the potash space, but you'd still like to explore an opportunity with us, submit your idea through the open house. And thank you again for all of your time, and hope to see you soon. Thanks, Holly.
Thank you, everybody. And we'll follow up with more answers to questions that are coming through at the end. So okay, let's back to you. Thank you so much. Great to see everyone, and have a great day, evening, morning, wherever you are in the world.